International GeoGebra Conference Regional Workshop Day 2. Okay. Already we had a session on 2nd, I think. Yeah, on 2nd, where we talked about a few tools. Like, I just want to just go through this once again. Point on the object, intersection. I hope you remember all these things. Point on the object, intersection. Then we talked about line segment, and segment with a given length. And I used a vector also. Then I think we also did on perpendicular and parallel lines, perpendicular lines and parallel lines, perpendicular bisector, angle bisectors. Okay. Then I used the polygon tool. Then I used the regular polygon tool. Then we went through circles, different way of drawing the circle. I think I did this 4 with you. Because ellipse, hyperbola, we'll do it later if there is time. Then we did how to measure angle, how to measure a line of a given length. Then we did a bit of slider. Then the move tool, zoom out. That's it. These are the tools. And I told you about the view, algebra view, spreadsheet, CAS. CAS is a little advanced. We can do that later if we get, maybe on the last day. Graphics, there are 2 graphics, graphics 1, graphics 2. 3D graphics, we will try to do tomorrow. Probability, spreadsheet and probability, I'll try to introduce it today if possible. Okay, these are the tools. So before we continue with our workshop, I would like you to just browse through and see all these things so that you get familiarized once again with what we have done previously. I'll just give you a couple of minutes, just go through it once. Just browse and see where each things are. Okay. So as a first activity, I would like to start with little basics only about quadratic equation. Okay. So I'm going to write a quadratic equation, ax, y. I'm going to use the text tool to tell you what I'm going to write. So I'm going to basically write y equal to ax square plus bx plus c. This is what I want to write. Y equal to ax square plus bx plus c. I don't know where it is. It should be somewhere. Y equal to ax square plus bx plus c. Okay, I don't know where it is. I can't see it. I don't know where it is. Anyway, we'll see that. We'll check that later. So in the input box, so as you know, this is the input box. So I'm going to type y. Before that, I'll create a slider. I'll create a slider. Say A. The slider name is A. I will increment it to say minus 15 to plus 15. Minus 15 to plus 15. Say incremented by 1 to avoid complications. Say OK. So I got a slider. I create another slider. Say B. This also I'll follow the same thing, like minus 15 to plus 15. Incremented by 1, or you can choose integer, it will automatically increment by 1. And I create a third slider. I hope you know how to do it. Third slider. Here also, I just keep it as minus 15. Not necessary, you can put any value you want. Minus 15 to plus 15. Just say incremented by 1. I have created 3 sliders. Now I want to move the slider around. See, I can move it. I can move the slider. Just you have to drag it. Finished. Suppose you want to avoid it from moving. Right click on it. Fix the object. Now you won't be able to move. Sometimes these things are funny. It's able to move. Okay, no problem. Now I'll type the function y equal to a. A is the slider that I've used. Ax square plus bx plus c. Now you got a straight line. Y equal to ax square plus bx plus c. Y equal to ax square plus bx plus c. You got a parabola. Ax square plus bx plus c. Now I'm going to just I'm going to press the move tool and then just change A. Change A to different values. You see, this is the best part of slider. You change it. You make it A as 0. You get a straight line because for a quadratic equation, A cannot be 0. So this is slide, and you can just move it around. Change B and C. So you explore it. That's all. Change C. See, C moves around. C is independent of X, so it only increases in Y. Because Y minus C. See, it moves around. So y equal to ax square plus bx plus c. A is 0, you get a straight line. What happens if A is negative? You get a other side parabola. Parabola symmetric about y-axis or parallel to y-axis. Just explore that and see. Just see this. When A is positive, you get a parabola symmetric about positive y-axis or parallel to that. When A is 0, it's a straight line because A cannot be, the coefficient of x square cannot be 0. And when it is negative, you get this. So this is the first thing that you should know. Drawing a parabola. I have used 3 sliders and I have drawn the parabola. Okay. Now, I want to calculate the discriminant value. Okay. So I will call it DISC. DISC stands for discriminant. You can give any name you want. Discriminant equal to C. In the input box, see what I'm typing. B square minus 4AC. Now look at the discriminant value. The discriminant value here is positive. Okay. Now let me change this and see. See, discriminant value is positive. is negative. Discriminant value is negative. If discriminant is negative, it has no real roots. It has no real roots. That means the curve does not intersect the x-axis. Now, if I change A, slightly if I change A, if I move this, look at the discriminant value. Discriminant value is 5. It's positive. It has real roots. It has real roots. Now look at this. Sometimes little difficult, so I'll make it discriminant equal to 0. It's not working. So if you move it around, you can see sometimes the discriminant value is 1. Maybe if I give real numbers, increment by 1, it will work. Okay. Since it is incrementing by 1, it is not intersecting. It is not touching the x-axis. Y equal to x square minus 4x plus 4. Y equal to x square plus 4x plus 4. Now you can see it is touching the x-axis. Discriminant value is 0. Discriminant value is 0. Roots are real and equal. Discriminant value is positive. Roots are real and unequal. Discriminant value is negative. Imaginary root. This is a simple demonstration. Here I'm sure you know this result, but what I'm trying to say is we are using different tools. I used a slider here. Okay, I used 3 sliders. Then in the input box, I typed the command y equal to ax square plus bx plus c. Then in the input box, I typed discriminant equal to b square minus 4ac. Then I change a, b, and c, and so on. That's all. Just I'll give you a few minutes time. Just try it once. Just try for yourself. Choose 3. Instead of giving increment as 1, we give increment as 0.1. It's up to you. You have to explore. Okay. I find it convenient to give increment as 1, so I did it. So give increment as 1. And 3 sliders A, B, and C. In the input box, you can also make a note later. If you don't want to try, you can try later. 3 sliders is A, B, C. Okay. Then in the input box, I type the quadratic equation y equal to ax square plus bx plus c. Then in the input box, I type discriminant is equal to b square minus 4ac. Then I vary a, b, and c to check whether it has a real root, imaginary root, and so on. Okay, that finishes this part. Now, let me introduce you to one more tool called. We have not finished all the tools. Remember that. I'm going to introduce you to one more tool called tangent. How to draw a tangent. Okay. So to draw a tangent, you need a point, correct? So I choose any point on the object. Any point on the object. Wherever you want to choose. Okay. Now I want to draw a tangent. So go to the tool. Click on tangent. See this. It's on this tangent. After angle bisector, click on tangent. Now you go over that. It will tell you what to do. Select a point and a function. Okay. So I'm selecting the point. I selected the point. I want to draw tangent at A. Now click on the curve. Automatically you get the tangent. Again, I'll repeat. First, you select a point. You want to draw a tangent. I want to draw a tangent. I want to draw a tangent at A. Now I want to, choose a point A. Now I want to draw a tangent. So click on the tangent. select the curve. Any way you can do. You can select the curve and the point, or you can select point and the row. So here I'll change the order. I'll select the curve and then I select the point, you get the tangent. Or you select the point and then the curve, you'll get the tangent. Try doing that. Now I just want to change the color. See how I change the color of the tangent. Right click on the line, object property, color. So I like blue color, so choose the blue color. So you got the tangent. I don't like the color of this point, so I can change that color also. Go on the point, right click, object, maybe for contrast I choose red. I got the point. So you have a red point and a blue tangent. So first what we did, we created a parabola, we created a curve. Okay, we created a curve. I took a point, then I verified b square minus 4ac and checked whether it has real roots, or real and equal roots, imaginary root. Then we are learning how to draw a tangent. So how do we draw a tangent? Take a point on the curve, you use the point tool, then tangent tool, and draw the tangent. And I changed the color. I think I already told you how to change the color last class. Today also I showed you. I hope it's clear to you. Okay. Now, what is the point in just simply drawing the tangent? I want to find the slope of the tangent, correct? So for that, I have a tool here. So look at this. In the angle tool, 1, 2, 3, 4, 5. The fifth one, you have the slope. So click on that and I can find the slope. So how do you find the slope? Go on top of that. It will tell you. Select the line. Select the tangent line. It will give you slope. So I go on top of that line wherever you want. Wherever. You click wherever you want on the line. Or you click on this equation. Doesn't matter. Click. You get the slope. See the word here. M equal to minus 3. Slope is negative. So the tangent is making obtuse angle. Slope is negative, tangent is making obtuse angle. Now, I just move around. See? What happened to the slope? Slope has become positive. The tangent is making obtuse angle. So when you move from negative to positive, it has to pass through 0. So that is the point where the tangent is parallel to x-axis. See that? Tangent is parallel to x-axis. So this you can explain increasing, decreasing function. Between minus infinity and I don't know what that point is, it is decreasing. And then from that point to infinity, it is increasing. Now I want to find this point. How to find this point? Very simple. You have a tool for that. Go to this point, you see extremum. There's something called extremum. Just click on that. It will give you the extreme. Click on that. And now select the curve. If you select the curve, it will give you the extremum. The point is given to you. So between minus infinity and minus 3/2, it is decreasing. And minus 3/2 to infinity, it is increasing. So you can do a lot of things in one activity. From 10th standard, you can go to 12th standard. Just try it. Again, I'll repeat. 3 sliders, I drew a parabola. Y equal to ax square plus bx plus c. That I typed in the input box. Then I calculated the discriminant value by typing b square minus 4ac in the input box. And I checked whether it is negative, positive, 0. Based on that, we are able to determine the nature of the roots. Then I choose a point on the curve and I drew a tangent. I choose a point using this point tool, and then using the tangent tool, I drew the tangent. Then using the slope, I found the slope. Then I moved the point, okay, to check what is happening to the nature of the slope. It changes from negative to positive. Then I want to find this extremum. Extremum means it's an optimum value. It can be maxima or minima. Here it is a minimum. So how do you find that? Go to the point tool. Here you have an extremum. So you get it. So we have almost covered all the tools here. Okay? All the tools. I can just go around, nothing will change. No properties will change. That is the best part of this. No property will change. Suppose I want to find the roots of this. I want to find the roots. There are two ways you can find the roots. One is we can use the intersection tool. We can use the intersection tool. Intersection of what? Curve and x-axis. Oh my God, it's not funny. Curve and the just come. Curve and x-axis. So you got the two roots. Roots are real and unequal. Now we'll just make this as 4, and I make this as 4. Now the root is -2, 0. Roots are real and equal. Lift it up. Roots are undefined because here we are talking about real numbers. We are not talking about complex numbers. So roots are undefined. See that? How nicely it comes. That's another way you can find roots. Now, what's the other way to find the roots? Now go to this tool. See, there's something called roots here after extremity. Click on that. Go and just click on the curve. It will give you the roots. It will give you the roots. So either you can use point of intersection to intersection. So intersection of the curve with x-axis. Or you can use the root square. Root. Just click on the curve, you get the roots. Okay. So in one concept, you can literally do so many things. Y equal to ax square plus bx plus c is the parabola. You calculated the discriminant. You found the roots. You understood the nature of the roots. You took a point on the curve and drew a tangent, and you found the slope, and you understood whether it is increasing or decreasing. And there you also found the optimum value. That is the minimum value. So this is a very simple activity where it covers literally all concepts across classes from 10th standard to say 12th. Any question? Anyone? Would you like to try for some time? I'll just give you 2 minutes time. Just try all these things. Take a couple of minutes to explore these things. And minimum has become just move around. So today I introduced you to new tools. First tool is Extremum, how to find Extremum. Second is I introduced you to roots. Someone's mic is disturbance, please unmute yourself. Please. Okay. I talked about Extremum, I talked about the roots. Today we did these two tools. Then I also told you how to draw the tangent. Then I also told you how to find the slope. Okay, so I have introduced you to 4 tools today. Okay. Okay. Now one more tool I want to tell you. Like choose a point wherever you want. I'm choosing a point here. Okay, choose a point. Now I want to find image of this point on this line. Very simple. Just go here. Reflect about a line. So click that. Choose the point. Choose the line. You get the image. Reflection. So this is also a tool, very important tool. Okay. reflection about a point. Suppose I want to find the midpoint of this. How do I find midpoint? See, there's a tool here, midpoint. Click on that. Click both the points. You get the midpoint. So, new tool. You learned midpoint tool now. You also learned reflecting about a line. Suppose I choose 3 points. I choose 3 points, wherever I want. Okay. I want to find the reflection of this point on this point. That is also possible. Reflection about a point. Choose that. So select the point, reflect it. You get it. So there are so many tools. You can just explore. Remaining tools, if you explore, you will understand there's nothing in it. Okay. So once again, as a recap, today we did midpoint. Then I talked about the extremum. Then I talked about the roots. Then we learned to draw tangent. Then we learned to find slope. Then how to reflect a point about a line, reflect a point about a point. Just take few minutes to go through all this. Just few minutes. Then I will take you to the next one. Okay, I think I gave you some time. Now I want to continue. I just want to type few functions and see how they look like. See, I'm going to type a function y equal to x cube minus 3x square minus 5. Some curve. This is the curve. I think I'll remove this 5 because it's creating nuisance. This will be much easier to handle. Okay, this is a curve. So I just took x cube minus 3x square. So you type this and try to do whatever I told you now. Draw a tangent, find the roots. Okay, find the roots. I want to find the roots. So click on this. First you type and check all these things. You can type any other function you want. You can find the roots. Click on the root, click on the curve. So it has 3 roots, 0, 0, and 3. 0, 0, and 3. 3 zeros, because it is a cubic equation. All these things you can explain to them. A polynomial of degree n will have maximum n minus 1 bends. So this is a cubic equation of degree 3, it will have maximum 2 bends. It can have less than that, but it cannot have more than that. It will have maximum 2 bends. I don't know whether we have studied in higher classes when we are doing a theory of equations, Descartes' rule of change of sign. Based on that, we try to calculate how many real roots and how many imaginary roots are there. So we can use these tools to establish that. Okay. Now you can draw, then you can find optimum value. See this extremum. Click on it. 2 extreme values. Two extreme. I'm only talking about the extreme values. I will hide it. See how I am hiding. Just look at it. If it is dark, you can see. If you hide it, now choose a point on the curve, wherever you want. Select the tangent tool. Click on the curve. Click on the point. You can draw a tangent. And select the slope. Click on the curve line. You get the slope. Slope here is positive. Look at it. Slope is positive. Now you can just move around to see what happens to the slope. Slope is 0. Then negative. Then again it is 0. Again it increases. So very simple concept of increasing, decreasing function. Simple concept of first derivative test where you can talk about maxima and minima. A lot of things you can do with this. So I hope you explored this. Y equal to x cube minus 3x square. And whatever I did previously for the quadratic equation, you must have tried for the cubic equation. Now, I will do slightly difficult one now. Slightly, I don't know whether it is difficult. I'm going to do a word problem in maxima minima. Okay? I'm going to do a word problem in maxima minima. So first I'll state the problem. I'll try one. You can do any word problems using GeoGebra. Okay? But it is slightly difficult. So let's see whether you are able to get it. A wire of length 10. I can't say meters. 10 units. Okay, is cut into two. Is cut into two pieces. One is made into a square and the other into a circle. What should be the length? Length of two pieces so that the combined area of the square and circle is minimum. So this is a question. I don't know why it is not coming. It is supposed to appear. Maybe it is some color problem. Let me check it. Ah, it is white in color. No wonder. It was appearing before also. Okay, good. Just come now. Just have a look at this problem. I'm going to solve this problem. A wire of length 10 is cut into two pieces. One is made into a square. It's cut into two pieces. Put in the next line. One is made into a square and the other into a circle. What should be the length of the two pieces so that the combined area of the square and circle is minimum? So I will tell you step by step. Maybe you can make a note of it and you can try later. As I said, it may be slightly difficult. We'll give it a try. Now take a line segment of given length. Line segment of given length. So whatever tools we have used, okay, we have learned. I'm going to use it in a problem in class 12th. This is a very simple problem in class 12th. So I will select a line segment of length 10. Just look at it. I got a line segment of length 10. Now I'm going to cut it into two pieces. So now where am I going to cut it? So I'm going to cut somewhere in between. So choose a point on the object. Choose a point on the object. First, I drew a line AB of length 10 using the line segment. Segment of given length. Segment of given length 10. If you click on that, it will give you automatically. If you want, I'll show it to you once again. Line segment Click wherever you want. It will ask you for the length. You mark it as 10 of given length. Now choose a point on the object. So this is where I'm going to cut. So I'll cut somewhere here. I don't know where I'm going to cut. So I cut here. So the point where I cut is called C. So clearly you can see you can move the C wherever you want. It doesn't go beyond that. It's a variable. Am I clear? Now I'm going to take the side of the square as A, which I have to calculate. So what will be the side of the square? I'm going to take this AC. I'm going to take this AC, bend it and make a square. So the side of the square should be AC by 4. The perimeter of the square. The perimeter of the square is 4A. So 4A should be equal to AC. So side of the square will be AC by 4. I hope that is clear. So I got the length of A. A is the length. A is the length of the square which I'm going to construct. Now how to construct that square? That is a little tricky thing. First I take a line segment of length, given length. Now click wherever you want. Click wherever you want. Click, it will ask for length. Press A. Okay. So you got a line segment of length A. Now I have to construct a square on that. So take a regular polygon and click that. You get the regular polygon. You get a square. And you can use the move tool and pull it down. So it's overlapping on that. So again I'll repeat. I'll repeat it once again. I want to calculate the side of the square. Side of the square is A equal to AC by 4. AC by 4. That will give you the side of the square. To construct the side of the square, I need a length. So I call it a line segment of length A. So I got the line segment of length A. Now I'm going to draw a square on that. So choose a regular polygon. Choose this. It will ask you how many sides you want. 4. Okay, you got the square. Now this is a square of side A. This is a square of side A. And what is A? AC by 2. AC by 4. I hope that part is clear. First I chose AB of length 10. I chose a point C in between AB. Then I took AC and divided by 4 and I called it as side of the square. That is A. Then I constructed the square. Is it clear? Now what happens? It takes some time. Just go see whether you follow that. Now I'm going to calculate the radius. What do you think is the radius? I call it R equal to, 2 pi R is BC. So R will be what? BC by 2 pi. R equal to BC by 2 pi. So I got the radius. See, A is the side of the square, R is the radius. Now I have to construct a circle. How do you construct the circle? Use the circle to see whatever tool you have learned, I'm using it now. I choose a circle. I use this tool, circle with center and radius. I choose that. I click wherever I want. It will ask for radius, type R. Very good. I made a mistake with the radius. Let me check what the mistake is. I think I did not put bracket. Okay. Sometimes you never know why these things don't work. Sometimes it works, sometimes it doesn't work. It should work now. Fine. It has understood it as BC by 2 into pi. Okay. So it is actually BC by 2 pi. So you put 2 pi. If you face such problem, you put BC by 2 pi. Sometimes it works, sometimes it doesn't work. Okay. Now it's finished. Now I constructed a square and I constructed a circle using this length of the wire. Now you just move this point C and C. See this. So nice. So it will change. Okay. But it's not over. If you notice here, poly 1 is the area of the square. Poly 1 is the area of the square. I don't know the area of the circle. So I need to calculate. So how do I calculate the area of the circle? ARCIR. I am taking ARCIR as area of the circle. I have to create the formula. What is the formula? I in bracket R square. Very exciting. Sometimes they don't work. I R square. How it works? It was asking for bracket multiplication sign. Sometimes it works with it, sometimes it doesn't work. I R square. Where is area of the circle? Here, area of the circle is 1.68. Area of the polygon is 1.83. I need combined area. I need combined area. So I need the total. I call it total. Total equal to poly 1 plus area of circle, ARCIR. Enter. So that will give you the total area. Total area is 3.51. 3.51 is the area of the square plus area of the circle. Before I continue further, let me repeat once again so that in case you want to write down also, you can write. Choose a line segment of length AB. Choose a line segment of length AB using this tool. See this tool? Segment of given length. Using that tool, you can create a line segment of length 10. Now, choose point on the object and choose a point C, wherever you want in between A and B. Now, you calculate the side of the square. Side of the square, I'm taking it as small a, which is AC by 4. So in the input box, you type, see the input, I will just show you here. Input box, it will appear here, see. The side of the square is AC by 4. AC by 4 in the input box. Now I want to calculate the area of the circle. Before that, I need to know the radius. How to find the radius? Very simple. Look at it. BC by 2 pi. BC by 2 pi. That will give you the radius of the circle. Then you find, okay. Now you draw the square first. How to draw the square? Draw the line segment of length A. Then using a regular polygon, you can draw the square. Then using the circle tool, you can construct the circle. Then I find the area of the circle. Since I need the combined area, I take total. Total stands for area of the square plus area of the circle. Okay. Now, how will a minima curve look like? It will be like a valley. Until unless I see that, I can't accept its minima. Of course, you can explore it here and see. You can check it. See this? Look at the total area value. See, it is 7. Now it is decreasing. 6, 5. Slowly it's coming to 4.7, 4.5, 4.3, 4.3, 4.1, 4.7, 3.8, 3.7. Again, it starts increasing. 3.6, 3.5, 3.5, 3. See, from here it changes. See, this is 3.51. This is 3.5. it starts increasing. So my turning point takes place at this point, somewhere here. So I'm going to find that point. Very simple. Now, how do I find that point? So I'm going to plot this point. I'm going to plot P equal to, so this is point P. P equal to, I'm going to plot this point. P equal to, in bracket, x coordinate of C. Look at it. X coordinate of C. X bracket C means x coordinate of C. X coordinate of C. X coordinate of C, comma, what will be my y coordinate? Total area is my y coordinate. So my x axis is the length of the wire when it is moving around, the position of C, and my y coordinate is the total area. So if I plot a graph, I'm plotting x coordinate as C points, wherever C is changing, and my y coordinate is a total area, and I got the point P. Now what I do, I'm going to trace this point. See, there's a command called trace. It will give you the locus. It gives you the locus. I give C. Now I will move this around. I use the animation. So I'm using animation now, plus animation. Now you can see for yourself how the square and circle is changing, and see the parabola. What type of parabola you get? You are getting a minima curve, and see where it is getting minima. We'll see. We'll stop there. Somewhere here. Somewhere at this point. 3.5. 3.52. So the minima occurs somewhere here. So the minimum area is roughly 3.5. You can do through calculus and check whether the answer is correct or not. And you can also see the radius. I think I calculated it. It is 40 by 4 plus 5. Okay. So this is a very simple way of doing maximum minima, where I used almost all the tools. It is not just using the tools. You also have to think what input you should give. Okay, this is a very simple problem, but there are higher difficult problems. If possible, we'll try to do tomorrow, where we try to do maximum minimum in 3D. Let me see whether we can do on 3D, okay, if time permits. But this is a 2D problem where a wire is cut. This is a very famous problem in class 12. A wire of length is cut into two pieces. One piece is made into a square, other one into a circle. Okay. So what will be the minimum? Where should I cut the wire so that the total area is minimum? Very simple demonstration. You have another problem where you can construct an equilateral triangle. We can try it as an exercise. A square and an equilateral triangle. You can try it and see. Okay. So just to take some time and see whether you understand. At least you can write down few steps so that it will help you to create this problem later. I'll give you 2-3 minutes time to just go through this. Unless someone unmutes and tell me to explain again, I assume that you have understood.
Sir, can you explain the last part alone, how to construct the graph of this?
Yes, ma'am. One second. I'll repeat the process again for you. So, till here, okay, right, ma'am? Till here, this is clear.
Yes, sir. It is very clear till this.
Okay. Now I'm going to plot the point. So in the input box, I'm calling my point as P equal to coordinate. You know, for a point you need x coordinate and y coordinate. So I'm choosing the x coordinate as C. See, you remember C itself is a point. You see, if you notice C is a point. Look at the point C. It is 7.71, 2. I am not interested in the 2. I want only the x coordinate. So for that, the command, this is a syntax. Now what is the command? X, small x coordinate in bracket C. Now what it will do, it will select only 7.71. So for point P, your x coordinate will be 7.71. Now what is my y coordinate? Comma, my y coordinate will be my total area. My total area name is total. Whatever name you give, you type there. If you have given the name as total area, you type total area. Whatever name you have written here, see, here the name is total, so here also it is total. So point P is x coordinate of C, COD x coordinate, and total area. Total area is a number. I call it as y-axis. Right?
Yes, sir. It is very clear now. Thank you.
Okay. Now to trace it, you go on that point, right click on that point, and press trace. Okay. Now either you can give animation or you can manually move it. So you can manually move it and see whether it is maxima or minimum. So this is a very simple case of a minima curve. Okay, you can try a maximum rectangle inscribed in a square. The maximum rectangle. Yeah, maximum rectangle inscribed in a circle is a square. So that is a maxima problem. For that, you will get a mountain. So maybe if we get time, we'll try. We'll do it tomorrow. Otherwise, I hope this is clear. Can I go to the next one? Now we'll do a small bit of integration. I want to do little integration where I want to talk about limit of sum. Okay. This also I'm sure all of you know to a large extent, but how to do it on GeoGebra? Those who are doing it for the first time, you may have a little problem. So for that, what I do, very, very simple. Let us try to understand what is the meaning of area. Area bounded by the curve is nothing but breaking the curve within the limit, breaking the curve into small rectangles. If the number of rectangles become infinity, the width of the rectangle becomes 0. So you get a continuous area. Okay. So how do I do it? First, I'll take an example. I'll take a random curve. I'll take y equal to 2 times SQRT. SQRT stands for square root in bracket x. I got y equal to SQRT(x). I took a function, okay, y equal to positive square root of x. So you can also try if you want. Y equal to 2 times positive square root of x. In the input box, I typed y equal to 2 square root of x. Then what I do, I use a slider because I need a triangle. I need to run the triangle, right? So I take a slider. I call the slider as say A. Here it is. It's good. It's A. And in fact, I change it to N. So it's nice. Number of rectangles. Okay. So let us be very realistic. Number of rectangles cannot be negative. So the number of rectangles should be minimum 1. And here I'll make it say 75. Okay. You can increase it to any number you want. Increment has to be 1. The increment, you cannot have 0.1 rectangle. So increment is 1. Again, I choose a slider to be on the safer side. Choose integers so that it will automatically give you increment as 1. So the slider name is N. Minimum value is 1. Maximum value is 75. I'll choose 75. You can choose 100. You can choose 200. Doesn't matter. Increment is 1. So press OK. You get it. So here I'm trying to, this is very funny. Here I'm trying to move the slider. I'm not able to change the position of the slider. Okay. So why I'm not able to change the position, we'll see. Right click on it. See, there's something called fix object. It is ticked. If you untick it, you can move it. I hope I can move it. Yeah, thank you. It's moving. Okay. So if you don't want it to move, right click on it and fix the object. I hope it stays there. Okay, it stays there. Finally, it's listening. Okay. So I have created a slider, increment by 1, minimum value is 1, maximum value is 75. So you can just move around and see the values. Okay. Now, this is a command. If you want, you can make a note of this command. I'm going to write the command. See, this is called lower sum. The moment you type lower, it will give you a help. It says lower sum. Click that. Lower sum of what? Lower sum now, you are going to construct rectangle inside the curve. Okay, lower sum. What is my curve? F of x. Look at that. My lower sum, my curve is f of x. Now, what is my starting value? I want to integrate, say, from 1 to 5. Okay, I want to integrate from 1 to 1 to 4. I'll keep. Okay, 1 to 4. Number of rectangles. Number of rectangles is n. Well, I am not going to press enter now. Okay, because the moment I press enter, you'll get approximately a view. Now, what I want you to do is, integrate 1 to 4, 2 root x dx and see what the answer is. 1 to 4, 2 root x dx and find the answer. 1 to 4, 2 root x dx and check the answer. Root x integration is x power 3 by 2 by 3 by 2. If you apply the limit, I am getting 28 by 3. I am getting 28 by 3, which is approximately 9.3. The area of the curve bounded by the curve and the x-axis between 1 to 4. Area bounded by the curve x-axis between 1 to 4 is 9.3. Now let's see whether it is 9.3 or not. I press enter. So I'm getting around 9.17. Let's see what happens. Now this is the limit of sum. See, between 1 to 4, I'm in the interval 1 to 4. My width of the interval is 4. My width of the interval is 3. Okay, and number of interval is 1. My width of the interval is 3, and my number of interval is 1. My area is 6. Now I make it 2. Now my width of the interval is 1.5. My width of the interval is 1.5. Number of interval is 2. Now the area is slowly changing to, from 6, it has become 7.4. See this. It was 6. Now it is 7.4. Now make it 3. So this is what we call lower sum. There is an error here. See, there's an error. Some amount of areas left out because you are taking only 4 rectangles. Now if I take 5 rectangles, 6 rectangles, so you keep increasing. If you do it, you can notice that all those gaps looks like they are getting filled. You get the complete area. But actually it is not the complete area. Why? If you zoom in and see, you'll see it. I use a zoom tool. And I don't accept anything. So I zoom in and see. You see, still there is some error. So when the number of rectangles becomes infinity, you get the area. So this is the idea of limit of sum in integration, which you can demonstrate using GeoGebra. Okay. So once again, shall I repeat the process?
Yes, sir.
Yes, once again I'll repeat it. First of all, I type the curve y equal to 2 times SQRP. See, those who know GeoGebra, all this looks very obvious. But if you're doing it for the first time, these commands, unless you use it, you will not understand. Y equal to 2 SQRT of x. Automatically get it. You can also test one more thing. When we are doing, we can experiment and see. Put a minus sign and see. You get the next, the opposite one. Okay. And this too. Okay. Now I'm going to create a slider. See, I'm going to create a slider My slider name is n, and it is an integer value. Minimum value is 1, maximum value, to keep it say 30. I'll keep it 30. Why should I do the same thing? Okay, I got the slider. Now the command lower sum. Lower sum. Look at it, lower sum. Type, press and click on that. It will first will be function. Type f of x. Okay. And then I'm sorry, there's some syntax error. Bracket is missing. So f of x. Then it is asking for starting value, lower limit. We will change, okay, we'll put 1. Lower limit is 1. What is my upper limit? My upper limit is 4. Now, between this, how many rectangles you want to divide? N. Automatically get it. This A represents the area. Now you can run this and see. This is called upper sum. This is called lower sum. In mathematical language, it is called the left-hand limit. You know, you talk about left-hand limit. Now I'm going to talk about the upper limit. I'm talking about the right-hand limit. You can also find area by calculating the area from outside. Okay. What will be the command? Upper sum. See, this is called upper sum. First one is the lower sum. Now I'm calculating the upper sum. F of x. Upper sum f of x. Starting value 1. Ending value 4. Number of rectangles is n. Now for the time being, I will shut down this A. Now look at only the upper sum. Look at the upper sum. Look at the area. I'm going to change. See this? You'll get the same area. 9.3. Here I took only 20. A 30 rectangle. If I make 75, I'll get the answer. Can you see it? See the upper sum. This is the right-hand limit. Okay? This is my left-hand limit. Left-hand limit, right-hand limit go inside, you get the area. Now, just for convenience, I'll just change the color slightly so that you see the difference. Blue color. So I'm making the the lower sum as blue, and upper sum will remain as red. Any question? I hope you got the syntax. Upper sum, function, lower limit, upper limit, number of rectangles. Okay. Now I'm going to introduce you to some small little scripting. Okay, little scripting, not too much. I'm going to use this button tool. I want to show you how to use this button. So I press the button. Click on that button. I want to start. I want a start button. You know, there's something called start button. Now, what is the syntax? Capital S. It should be capital S. S-T-A-R-T A-N-I-M-A-T-I-O-N. Start animation. Start animation. S is capital letters. Bracket N. Start animation N. So you got a start button. Now let me see what exactly it does. I press the move button, okay, and then I click on start. See what happens. So this is a very simple animation. How to use a button, start button. Now this is never ending, it never stops. So I need to create a stop button. So click on that, press, you create a stop button. Now how to create a stop button? The animation is, the command is start, capital S, start, A-N-I-M-A-T-I-O-N, start animation, in bracket. This is a Boolean operation, okay? So you have to say false. The moment you say false, now you see what happens. I will press move before pressing anything. Stop. Animation will stop. Start. The animation will start. Stop. It will stop. But I don't like this way of stopping. I wanted to go back to the original value. So what I do, I create a reset button, R-E-S-E-T, reset button. So how do I do? Start animation in bracket false, because it has to stop. Start animation false. Then initialize the value n equal to 1. If you know little programming, you can do this. N equal to 1. So very simple program. There are more complex programs that you can explore and find out. Now you can see the difference. This is start, this is stop. It stops there. Start, stop. It will stop, but it will go back to the original value, n equal to 1. It will go to the initial value. In fact, you can bring it to any value, but here I wanted to bring it to the initial value. So start, this is stop. Start, this is reset. Reset and stop. Okay. So if you want, I'll repeat it once again. How do I do it? Go to the OK, the button. You see this button here? Button. Click on the button. Whatever you want to type, you type. Hello. Okay. If you want to type hello, you type hello. You say start animation in bracket start animation n. Because only this can be animated. Okay. There are many other commands. We will not go into those things now. We'll do only simple things. If you know this much, you can, for school level, this is it's more than enough. Start animation n. That means animation will start. How it will start? With the value n. So animation will run for n. So n is a variable, so it will move. Now, how do I stop? Same thing. Start animation, you give false. Because false true is a Boolean operation. Okay? You're telling false. That means start animation false one, you should not start. And if you want a reset button, you add one more stage. What is that? Put n equal to 1 or n equal to 0 or n whatever you want, you put it. It will come back to the value which you want to start. I hope it's clear. If you want, anyone want me to repeat this start button tool, let me know. Press the button tool, click wherever you want, and the caption is your choice. You can put your name, and then you can say start animation. Here I want to start animation. Start animation, syntax error on the pathum. And for starting animation, it is start animation, S capital letters. For stop, it is start animation, false. For reset, start animation, and then reinitialize the value, n equal to whatever it is. Are you clear with that? Okay, the next one is, I just want to show you one more tool because I want you to be exposed to all the tools. Checkbox, how to use this checkbox. Okay. So I click. Show lower sum. I'm creating a checkbox to show lower sum. Click on that. It will show the function. It will show the lower sum. Apply. Again, I click on the checkbox. I create one more checkbox. What is that? Show upper sum. Click what all you want to show, function, and then you want it to show the upper sum. Apply. So I have created two checkboxes. Now click on this. So it will show you only the I think I did the other way around. Okay. So you change the name. So I did the opposite way. So don't bother. Change the name here. That's what. We can change it. Object property. Show in the page must but if you want to show a person, you can show the person. I did it correctly. Okay. Remove both. Okay, remove both. Show lower sum. Okay. You don't want to show the lower sum, remove it. Show the upper sum. So here I think I made a small error. Object property. Const scripting basic. Yeah, function alhamdulillah. Okay, yeah. This is the tool. I'll repeat it once again to you. Checkbox. Click on that and you type show lower sum. It will show you the function and it will show you the lower sum. Apply. So show the lower sum. So it will show you the lower sum. If you wanted to show the upper sum, you have to type again show upper sum. That's the curve function and then the upper sum. Apply. Now you can see for yourself both. If you want to see the lower sum, you can see it. If you want to see the upper sum, you can see the upper sum. This is a very simple tool. So what I'm trying to tell you is how to use this button, how to use this checkbox. Okay. So these tools also we covered. Any questions on this? If you have any question, you can ask me. Then we'll go to the next one. Now I'll tell you a little bit of statistics. It's clear? Shall I move on? Now I want to do a bit of statistics. So go to spreadsheet. See, in the view, you press spreadsheet. Now this is the X value. I see in the spreadsheet, just like the way you use Excel. 5, 10, 15, 20, 25, 30. Excel. Now choose the frequency. The frequency is 2, 6, 3, 8, 9, and 10. I've chosen all this. So I want to take it as a point. How do you choose it as a point? You know, in Excel, for every formula, you use equal to sign, correct? Bracket. Choose this point. Choose that cell, comma. Choose this cell. Press enter. You get the point. The point is 5, 2. Again, I repeat. Equal to. Equal to means formula. Open the bracket. Press this cell. It will tell you A1 cell. A1 cell. You can understand matrix through this, comma, B1 cell. Press enter, you get the point. No need to type. Otherwise, you have to sit and type. Now hold this corner and just pull it. You get all the points. Okay. This is one simple way of writing it. Now, when we are doing all this, something happened. What happened? All these things got plotted, but you are not able to see. Now, how to see it? Click here, go on the x-axis, see that horizontal line will come. Just move. So you'll get the scale. You can reduce the scale. You want to go up to what? 30. If you go up to 30, you get all the points. You see, all the points are there. Every point you've got. This is called scatter diagram. That is exactly what is given here. Line of best fit. Click on that. Select all the points. You get the line of best fit. Okay. Statistics, line of best fit. Other one is a scatter diagram, line of best fit. Now, once again, if I'm going fast, go to the Excel. I only type the points. I type the points. Now, how do you get the points? Equal to. This is one of the ways. There are many other ways. Okay? You can use list command and get it. Bracket. This point. It's a very easy way to get. Comma. Click on this. And press enter. You get the point. Now go there. At this corner, pull it down. You get all the points. Every point you get. Now I'm not able to visualize those points here. So what you do? Click on the window. Only then you'll go to the graphic tool. If you click on this, you go to the statistics tool, spreadsheet tool. If you click on the graphics tool, then you go to the graphic tool. See the difference. See, if you click on the spreadsheet, you go to the spreadsheet view. If you click on the graphics, then only go to the graphics tool. Now, this is what you have to select. Move graphics view. Go to the x-axis and just slide that nicely. Now you can see points in the picture. Okay. All of it. 30 varaikkum podum 30. Now you can see literally every point is there. How do you do line of best fit? Select line of best fit and select all the points using the rectangle tool like this. Just select them. Automatically you get line of best fit. Okay. Now how to draw histogram? Select this. Come over here. Histogram. Okay. The histogram, go to settings. Select. You have to explore. This is all not that easy to explain. Class interval. It will give a class interval. Again, I'll do it. Select it. Or you select one. No issues. Select one. Or don't select. Doesn't matter. Go to histogram. Now here you see there's a settings button. Click on that. Okay, good. I understood. It's not working because I didn't select anything. Congrats. Okay, now select this point. Settings. Class interval. So what should be my class interval? I will say 0. My width is 5. Not possible. Sometimes you never know what happens. Select all this. Histogram, settings, class interval. Well, I really don't know why it is not working. It was working. Oh, I understood now. I have to select this. This is Okay, I got it now. Now, select all this histogram, settings, class interval. See this hand, select that. Now here I don't want this, so I want these things. So got the histogram. This is not the right histogram. Just a second, please. Settings, class interval, hand. Okay, now I got it. 0 to 0 to 5. Analyze. So you got a beautiful histogram. This is correct. So I'll repeat it once again for you. First, what I do, I select this, go to the histogram, class interval. You see there's a hand here, select that. It will give you the frequency. But my class interval is not appropriate. So go to that cell, select now this, analyze. Automatically get it. Here also there is some problem. Sometimes you don't know why it misbehaves. Just a second, please. Give it one last try. I don't know, something is wrong. Huh? This is not coming. This is what I was trying all this way. One last try. So go to this and select this. It's coming in the reverse order. That's the problem. Zero to 5. Okay, now I think it's come. So 0 to 5, 2. So this is creating histogram. You just explore, you'll get it. From this, you can create a lot of things. You can go to probability calculator. You can get normal distribution. You can get Poisson distribution. You can get Pascal. You can get a binomial distribution. Literally everything you can do, every calculations you can do. Okay, those statistics. This is probability for you. This is statistics. In statistics also there's a lot of things. For some strange reason, other things are not coming. I don't know why. Okay, anyhow, let's not waste our time in it. So you can calculate everything. Ah, here it is coming. Normal quadratic bar chart. Okay, that's it. I don't know why it's not working. Okay. So this is something about statistics and probability, which you can explore and see. And if there's any question, you can ask me. And I'll show you one more thing, which if you want, we can do tomorrow. This design. You can create this design using GeoGebra. Are you able to see the screen?
No, sir.
We are not able to see the screen.
Just 1 second. I have to share now. Just a second, please. Just a second. Percent. On this design. We will do tomorrow. It will take time. You see, you can create this design using GeoGebra. It's very interesting. You see, it is from circle. Nothing but a circle. Circle and point. And when I move the slider, you can create it. This is a very simple concept of a problem in 11th standard. How many diagonals you can draw to a polygon of n side. That's all. Use that idea. You can create a wonderful. It looks very beautiful. So maybe if you get time tomorrow. Tomorrow, what is my plan is, I'm going to do 3D geometry. But I'll talk to you about planes. I'll talk to you about straight lines in 3D and maximum minima problem. And we'll also explore GeoGebra tube, where some resources are available and how to use those resources. I learned all these things only by looking at those resources. So I'm sure you all can learn by searching the net. It's a wonderful tool and it's very interesting also. Something different from what we do regularly. You see, this is a triangle. You cannot draw any diagonal. See this? A square, a quadrilateral, you can draw 2 diagonals. Pentagon, see, you can draw, see how many diagonals you can draw. So basically, it is all about drawing diagonals. The moment the number of sides increases, you see what a beautiful picture you get. That's it. Okay, this is what I wanted to tell. I think our day 2 session is over. Thank you for coming. We'll see you on Saturday. Have a nice day.
Thank you, sir.
Right.
Thank you very much, sir.
Sir, next section is tomorrow or day after tomorrow?
Day after tomorrow, sir.
Thank you, sir.